Okay, welcome to this session. Operating safely equipment and technology. So we did a lot about people yesterday. Today we're going to focus a bit more on kit. So there is a warning in Ersin's presentation. There is a video containing flashes. So just be warned. Obviously, this is us, the three of us. So you've seen this diagram before. Just want to start with the hierarchy controls again. We've slept into yesterday, so just a reminder. You've obviously got the elimination, substitution. These we can't really do. Our hazard is the electricity. It's the thing we need. It's the thing we're using. So elimination, substitution aren't really a feasible thing here. But engineering controls are kind of where we're going to focus in this presentation. So on Slido, getting you going early on Slido today, got a quick poll. Has your company actually retrofitted any arc flash mitigation measures to older kit? I'm just trying to get a feel. So if you just put it in Slido, we'll revisit the answers a bit later in the presentation. So the thing is, on a lot of the time, yeah, it's easy to say new equipment, I'll put in all this stuff. But what about the old equipment? This is what we also need to consider. So, yeah, preventing electrical injuries. It's kind of two main ways of doing this. We can remove the person from the hazard. If they're not there, they're not going to get hurt. So restricting access, making sure that people can't get into switch rooms where they shouldn't be, and things like that. And then there's removing or reducing the hazard. So de-energizing, obviously the top one is de-energizing. If you don't have to work on it live, don't, which is our main point there. This is pulled out of our safety rules. I think there's very similar in many other people's safety rules. So work on exposed energized electrical equipment shall only be carried out where it is unreasonable for it to be de-energized, and it is reasonable for it to be worked on energized. So this is where you come in, you say, I can't do a phasing check if it's dead. That is a reasonable reason to work on it energized. The fact that I want to save half an hour is not a reasonable reason to work on it energized. So some of the other ones for reducing the hazard, we can reduce the fault current if possible. There's ways and means of doing that, or we can reduce the duration. Again, it's going back to that old equation yesterday. Time is a big factor in these things. And then by using insulated components and tools, we can reduce the probability of a fault. If a guy's putting in a tool that's got insulation wrapped on it, he's less likely to cause a short than if he's just putting in a bare metal tool. So going back again to removing the person from the hazard, one of the tools is remote switching. We'll go into that a bit later. Interlocks, we've had discussions on those. Mechanical interlock, track keys, again, there'll be examples later. Relay logic, can you, for example, a wind turbine, you've got intruder alarms on the door, can you use that sensor to actually switch off the kit before anyone goes in there? Just some ideas to throw around. Or remove the requirement to open doors or remove covers. The first one here can be controversial. Voltage indication on to show if the equipment's energized. People are, I'm not going to rely on that to prove dead. That's fair. But if I walk up to a piece of kit and the voltage indicator saying it's live, I'm going to do some extra checking. I'm going to make sure I'm on the right piece of kit. I'm going to go and make sure my isolation's good. It's just one more layer that we can use to reduce that likelihood and therefore reduce that risk. Thermal imaging windows, we have retrofitted these on one of our sites because you're asking a guy, the reason you're checking is because there's a risk of a fault, so you're then asking the guy to stand there in front of it with a camera. If you can do it through a window and give him that protection, then that's well and good. Temperature indications outside, oil sampling outside of cabinet. We've done this with small transformers, moved the oil tap in for the DGA outside of the cabinet. You don't then have to open it and actually be next to that kit. So just some ideas. So yeah, arc flash mitigation using electrical protection. This we had some examples of it yesterday. So we can reduce the current pickup level. This can, though, cause problems with discrimination. If you make it too sensitive higher up, then you lose more of the system. So it's something to be thought about. Again, with reducing trip time, are you going to interfere with levels further down? Maintenance mode, we've said this, so you can put more sensitive settings in when someone's working on it, but there are some issues on how this is used, because if you're relying on a person to switch it on, is it going to be switched on? So can you link it into when they put it into local? Can you link it to the door opening? Things like this. And then you've also got the issue of putting it back again after they've finished, so that you don't end up with these more sensitive settings in permanently. Sensitive directional overcurrent, this is one we've used in the wind industry. So when you're on a generation circuit, your highest effective loads when you're generating are going out of the wind farm. But when you have a fault, the fault current tends to flow in. So you can actually set the settings a lot lower than your generation current, because as soon as they're coming in the other direction, you know it's a fault. There are sensitive bits about load encroachment and things that you need to consider, but it's another one to think about. Light detection systems, I think we're going to have a lot more of that in Ersin's section, so I'm not going to go into that too much detail. Ultra-fast earthing switch, again, I think Ersin's covering that, so I'll leave that for there. Inter-relay communication, like goose messaging and things, you can now have a relay say, I've got it, you don't need to go, and things like that. You can actually effectively remove the need for coordination, because you can put everything instantaneous and just get them to talk to each other. So these are things you can do, and the technology's there. So just another poll. Actually, can we have the results of the previous poll at all? Is that possible? Or we'll come back to that later. But yeah, another poll for you. Which of these mitigation measures does your company use on existing equipment? And you should hopefully have some options to select there. And again, we'll leave that going while we move on. So I'll move on to Mark's presentation now.
Thank you, Jenny. Morning, everyone. We're going to capture aspects around safety and design. Now, my presentation, in my view, is about the absolute basics. The basics around how do we stop people from being in front of what could be dangerous. So we're going to keep people away, and we're going to discuss that around design, around spec, and around how we would operate. We covered a few bits and pieces yesterday, so we're going to go over it again. But aspects where you can do safety and design, so remote controls via SCADA. Some of us have got brand new installations. We get top of the range SCADA systems and control rooms. And obviously, when it comes to a retrofit process, not quite as easy to be able to do. But remote controls via SCADA, and we'll cover it in a minute around the hierarchy of switching, but if we can do any operation remotely, then we take the risk of the person being in front of any kind of harm. So that would be the top level. The ability to secure points of isolation and circuit main Fs. This is a free position switch. The nature of free position switches mean that in design, when you put the point of isolation in and you apply your safety locked and caution notice, you then cannot put it into the earth position or secure the earth position without removing the point of isolation. And most safety rules in the UK is you wouldn't be compliant to remove the point of isolation padlock at that point. So you have to write an agreed variation. But to save having to write an agreed variation, if you're involved in the early days of the design concept, people can have an input, can spec that we can do this. Some items of switchgear also actually can have the ability to apply the safety lock and caution notice in a safe manner. What you would just then have to consider is how do you kind of render it inoperative? How do you make sure that you can still select the earth position? It'll be based on design. Not every free position switch you'll come across is non-compliant, but some are. But if you can have some input into design earlier on, then you can mitigate that issue. Safe access requirements. So the picture on here is a capacitor and filter bank. The low-level buzz bar in that compound at 132, in that one specifically, you could just walk straight up and touch it. If you just had padlocks on those gates, normal padlocks on those gates, you could in theory enter that at any point and it would be energized and you've got an exposure risk there. So we fit an interlock door, Castell keys, those type of things, to be able to gain access. That then links to the safety precautions being applied prior to you being able to enter that. Also things like time delay considerations as well. There's a number of different ways that interlocks can be operated or used to control access. It's perfect when you're relying on isolations or earthing to be able to gain, to be able to make it safe to gain access into a certain area. The last thing you want to do is have a risk that is there and people can go in there without having to maintain safety precautions. So again, that's a consideration in design. You could retrofit it, or when you have if you have a modification, build something new extra on the side, you want to link it with one to the other. It's relatively simple to be able to add interlocking. So the hierarchy of switching. In our safety rules and in most safety rules, we discuss the hierarchy. So first and foremost, we'll do our operations remote via SCADA from a control room. At that point, there is nobody in harm's way. The SAP, the AP, whoever's going to be on that asset, a team of guys that are working doing something else, we can do this, and especially in the offshore wind area, we can do this, and the SAP still having his breakfast on the vessel. There's no way he's going to come into harm at that point. Yeah? And that's why that's number one. Great if you've got a fancy control room. Great if you've got the ability to do it. Actually, what we do on our new installations is we can do remote operations on everything. Circuit breakers, disconnectors, earth switches, everything, and our process is to do them all remotely. Keep everybody out of harm's way. In theory, all our AP's doing is going to put a padlock on at the end. Panel in a different room. Again, you can see the trend here. We're keeping people out of harm's way still. Totally out of the room. Nobody needs to be at risk when we're doing this. So, again, when you're considering design, you're putting all your protection panels in a different room. Have one of them with an open-close controller on there to do the breakers in the next room. Consider, again, furthest away as we possibly can from the risk. Remote operating device. Again, the main point of this is to be able to get as far away as possible. Best case scenario, out of the door from the room that you're in. Plug it in, through the door, press the button, you're out of harm's way. Similar to the next three. Numerous different ones. This one here obviously depends on the handle, can move onto the hand, or you can actually just do a wiring modification where you plug one in and just have an open-close button, send some signals in. And so it can 100% be retrofitted later on as well. Panel in the same room. We're getting closer to the risk now. But if you've got, up this corner, you've got your switch gear, and then up that corner, you've got your panel in the same room. Just think about layout if you're involved in the design process. Where should we put them? Yeah, don't put it right next to each other. You're not benefiting anything. Let's put it over the other side of the room. And then, again, we're keeping out of harm's way. The potential is still lessened. And then directly on the switch gear. We see a lot of pictures yesterday of people with all the gear on, pulling a handle, right? That's great. But let's consider if we can do that in a different way. Let's take the risk away. Let's do smarter switching. Can we achieve one of these first? So those involved with planning, switching, SAPs, writing switching schedules, control engineers reviewing and approving that process, this is what to look for. Have they done that via SCADA? If not, why? If they can't do it via SCADA, can they do it from somewhere else? Okay? If this is your bread and butter, day-to-day considerations, will keep people out of harm's way. Review isolation procedures. We talked about arc flash. There's a risk. You don't want to expose some people. Exactly the same as what we're discussing now around this hierarchy of control. But we just want to keep people out of the way. So we want to see if we can remove. So we consider isolations to remove the risk of arc flash. Fundamentally, that's what we want to do first. So we consider the hierarchy of switching. You've removed the risk of arc flash if you're nowhere near it. So we're going to isolate via SCADA, isolate downstream. We talked about it yesterday. Pick your isolations, take that risk away. Consider trap charge on GIS equipment. You know, that's a link towards other risks that need to be managed. Isolations to reduce the risk of arc flash. So sometimes we can't do the remove, so then we're going to have to reduce. Change protection settings, apply screening adjacent to live equipment. We talked about changing the protection settings. You can turn it into some relays have maintenance mode, some have normal operations. Again, consider how you control that, like Jennie said. It's okay applying a maintenance mode. Last thing you want to do is get off the turbine or leave a substation in a hurry and leave it in that position. Something small operates, and next thing you know, you've tripped your HV system. It's a bigger problem then. So make sure that is detailed in a process of how to make sure you remember to put it back. Apply screening adjacent supplies in LV panels. You might be working in this one. This one's remained live for whatever reason that's needed to be. Make sure we screen it with the appropriate stuff. Make sure we're managing that risk prior to us going into the panel. And then isolate by using an isolator on another panel. So instead of opening the door, like we saw yesterday, lots of open the door, pull the handle. Let's not do that. Let's look to say, okay, maybe we can even do a retrofit to do a rotary isolator on a panel door, on the panel in the next room, or the panel 4 panels over. Let's look at being able to just do that in a closed door away from harm's way, apply our padlocks, and then we're considerably safer at that point. De-energized, yes, we're going to prove dead, but the bigger risk is gone. Isolations with arc flash risk. Do we need to do it is the question. Why are we doing it? Why have we not satisfied these first 2 boxes? Yeah, think about that every time. You can get in a routine where it's simple to just say, oh yeah, we just go on there, get the gear on, pull the handle. We've always done it. Consider it. Actually, do we really need to? 100% we're going to have to use the correct PPE at that point. Also, consider the environment that you're working in. Safe access and egress. Right? Sometimes switch rooms can be cluttered, like we talked about, someone's using it as an office. There's a storage facility, or you've only got one way in and out. On a wind turbine, sometimes you might have to climb 2 sets of ladders to get out. That brings a different risk to consider. Yeah? So, safe access and egress. Make sure you can get in and out if there was an issue. Don't do it on your own. You want someone there to help you if something goes wrong, don't you? So, get a couple of you there. Make sure that they all understand the risk. Make sure that they all understand what to do if it did go wrong. Make sure they know what you're doing. Because at that point, you might have a discussion with them, and they'll go, what are you doing that for? We just go next door and turn it off. And you go, oh, yeah, I didn't think about that. This is what we've always done. Insulated tools and the correct labels. Labelling, we mentioned many times yesterday. Understand the arc risk, understand the values, understand the PPE required. If that's on a sticker on the front of the panel, then you can all comply. Insulated tools, yeah, if there is a risk that you could drop something, touch something, it's just good practice to use the correct tooling. Example of the PPE, depend on the calorie rate and depend on the risk, depends on the PPE. You can highlight that on your signage. You can make sure you cover that in your processes, risk assessments, method statements. Let's not let that be a surprise when you turn up and go, I haven't got the right kit, but that will do. Let's not have that. Let's plan the work, make sure we know about it. Insulated tools, testers, normal tools, use the correct calibrated equipment to use. Okay, don't put yourself at risk by just using something that's not fit for purpose. Also, make sure you use something that is fit for purpose, because you don't want it to say, give you a false reading because you're using the wrong tester. And access and egress, as I said. This one's on a new build or some work that's being modified. That's great, but tomorrow there could be a massive hole out the front of that gate where they're doing some cable joining work. You don't want to be working there without being able to get in and out. That might be the only door. Modern day substations normally have 3 or 4 doors. Leave one open while you're doing a certain work, whatever, but manage that. Again, on a wind turbine though, especially an offshore one where you have the monopile aspect, you could have the switchgear a level below. You only have a hatch this wide, 2 sets of stairs to get you down into there. So if you do need rescue, if you do need to get out of there, if the switchgear is in distress, consider that when you're planning your work. Consider that when you're talking about the hierarchy. Don't put yourself down there if you don't need to. Challenges. As I've mentioned, switchgear in the lower levels, we've also got lots and lots and lots of low voltage panels in a wind turbine. If you're working in any one of these, you've got to consider the risk to the one behind it, the one next to it, and the ones around you. You're not going to be able to de-energise all of them, otherwise you'll probably not be able to operate the plant, equipment. Lights might go out, whatever. So you're going to be working in one, but consider that. If you're going to expose yourself to arc flash risk, you physically have to be able to do that isolation, okay? Arc flash boundary is a thing, depends on the calorie level. Arc flash boundaries might actually take you too far, and you're in the sea. So you physically can't manage that due to the nature of the design. You just need to consider how to do that in the best way to take that risk away. Again, that's around planning. What we've done is when you work on a wind turbine, you follow this AWP process, proof work procedure, which is how to isolate mechanical and electrical systems while working on a wind turbine. What we did as a company is then, once we actually recently had some arc flashes done on a couple of arc flash calculations done on a couple of sites, and then we took those calculations and then said, right, how do we take this risk away? So we reviewed every single AWP and said, is it enough? Can we do a downstream isolation? Can we do an operation remotely? Can we put it into a condition where the harm is gone? So that's about review. That was a simple task to review a process. A couple of changes, but that might be a couple of changes that could save somebody. So it's well worth doing. And that is it from me. So I'm going to hand over to Ersin, who's going to talk about the technologies available.
Yeah, thank you, Mark.
Yes.
So first, thanks to Schneider for this opportunity. Me, Ersin, Danaci, looking after protection layers and RTUs for Schneider Electric. And I will be going through the technology side of the arc flash mitigations. Most likely I will start with the first slide. So yeah, I want to recap about the arc flash mitigation. We started with the first risk assessment. Then we talk around the system study, arc study, and energy calculations. Then we talk about arc mitigations, like PPE, like passive protections, like arc energy tunnels on those switch gears. And now I will be talking about more about active protections, which is with the arc flash protection relays. So on this slide, you can see various options, solutions for the mitigations. We have here differential protections, impedance, ERMS, and arc mitigations with the arc technologies. So there are a different reaction and response time from the products. Obviously, from the start of this event, we are talking about time is very crucial because we have to clear the fault and the explosion as soon as possible, as quick as possible. So as you can see from the chart, arc flash technology has quicker response, quicker detection, which is 1 to 2 milliseconds. And if you count the also circuit breaker operation time, which is around 50 to 80 milliseconds, so we will able to manage to isolate the faulty circuit less than 100 milliseconds. Because over than 100 milliseconds, the explosion could, the result could be death. For that reason, we need to isolate the faulty circuits as soon as possible. So for example, for the differential protection, we can utilize also a busbar protection. It's another mitigation. But for the busbar protection, we may need to use specific CTs. That means it will be a bit more expensive. And also, if you consider the low impedance protection, then we may not be able to protect the cable compartment. So there are some disadvantages on the different mitigations, but that's the reason we are advising the arc flash technologies, which is specifically designed for this type of application for the arc flash issues. So in this chart we have different calculations regarding voltage level and the time. On the up column, you see that when voltage level is increasing, power flow increasing, obviously the energy and the calorie is increasing. And if you on the left-hand side, as you can see, when the time is increasing, the energy is reducing. This is again highlighting that on the first instance, on the explosion, it will give the highest damage. That's the reason, again, we need to clear the fault. We need to clear the faulty circuit as soon as possible. As you can see, there is a color code here. So the color code just highlighting that how important it is to utilize the arc flash technologies for the high volume energy sections. So on the solution point of view, there are various technologies. So in the past, we would have traditional arc flash protections. It's a separate item, and then arc flash relays was a separate item. But now we are coming to merging arc flash and the traditional protection relays in one box because the demand for the arc flash mitigation is increasing. And we try to really provide the most optimum solution. As you can see in the picture, we have here a single MV switchgear, and it's just it is pointing to where we can install the sensors, because the difference between traditional protection relays and the arc flash is the main key is the input. So on the protection relay, we use instrumental current transformers. On the arc flash, we use optical light sensors. So this is one of the key differentiation between traditional protection and the arc flash technologies. And where we can use the optical sensors, as you can see, we can utilize on the bus bar, we can utilize on the LV compartment, and also cable compartment, or also as well as a circuit breaker compartment. As much as we use light sensors, we will increase the sensitivity. But also, in the meantime, we need to think also about optimum solution. So, and this is, again, depending on the calculations, energy calculations and ARC studies. So based on the report, we will able to define the best design and best solution based on the, again, ARC study and the calculations. So I think it's important to highlight here as well. Yes, we have 1 to 7 milliseconds, 1 to 2 milliseconds response time from the ARCs, but there might be some applications that we may need to also use the current input because to avoid any kind of unwanted trip. So then we can move up from 2 seconds to 7 milliseconds, considering to also a current input from the instrumental current transformers. So there's a video here. Yes, the result will be really catastrophic. Again, the temperature go up to 20,000 centigrade, 10,000 kilopascals. So it's a huge impact on the explosion. And I mean, there's a research that in US per year there are up to 5,000 arc incidents happening, and maybe up to 400, 500 people injured. So that is quite important for us to really develop solutions and mitigate this risk. So on this slide, we see various optical sensors. As you can see, we have point sensors on the right corner, and we have also fiber optic loop. The difference is really point sensors, we utilize more MV applications. It's because it is easy to install, especially for the retrofit projects as well. And it's also quite easy to set it up with the application. Whereas fiber optic is loop we use for the LV switch gears, because we will be having more sensors, and it will be easy to, again, it will be cost effective to utilize the fiber loop on the LV switchgear applications. So here we have some examples for the LV switchgear. As you can see, there's a single line diagram here. We have blue color is the loop for the fiber optic circuit, and the green line is the communication between extension tools. Usually, if it is more than, let's say, 20 or 30 switch gears, we propose to use a central unit on the main board, and also extension modules for the other LV circuits, just to utilize more optical sensors. So, as you can see here, there's one option here that's shown on the green circle, where we install the point sensors. It comes with the L plate or Z plate for easy installation, and it could be cost effective in that respect. So for the design point of view, again, coordination is important, zone protection is important, and when we increase the sensors, of course it will increase the sensibility, but we need to also consider about the coordination and the zone protection for a quicker response and for avoiding any kind of unwanted trip, to cover also all type of scenarios in the application. So here again, we just demonstrate where we can install the point sensors. Here we have the LV compartment, bus bar, and the cable entrance for the point sensors. And it is also quite easy for the retrofit applications. For the technology point of view, so again, for the MV switchgear, we can use standalone protections. But if we have a multiple substations in different locations, then we will need a coordination. And then in that case, we may need to utilize a central intelligent device that can communicate with the extension modules. And this requires, of course, the communication between central unit extension modules. In each extension module, we can install up to 10 sensors. And with on the central unit, we can install another 10 sensors. So considering number of sensors, we can decide number of extension modules. On the more complex systems, we have also other options with the communication module with the fiber optic loop, which will make it more, again, cost effective and they cover the different scenarios on the applications. Yeah, why arc flash protection? Definitely is first a main reason is to protect our electricians, technicians, and people. And another important point is to protect our infrastructure, critical assets. And in that respect, deciding the right solution based on our assessment, based on the calculations, is quite important. In that respect, people and infrastructure, and reducing the outage by avoiding unwanted trip. The reduced risk of fire, up to 22% of fire caused by electrical failures. So definitely it's another key item that we can reduce the risk of fire with the arc mitigations. Yes, reduce the downtime of equipment for the, again, weeks or days, because unwanted trip could be causing more damage on the infrastructure, on the switch gears. So this will cause, of course, longer outage, which will increase, reduce the productivity. And reduce also equipment repair cost. Definitely, if we can isolate the faulty circuit on time, then we will have opportunity to either repair or protect completely all our switchgear or infrastructure. And of course, continuity service for the other equipments another element for the arc flash mitigations. Okay.
Thank you, Ersin. Sorry, I was making notes there as well as scribbling as you finished. All right, thank you. Let's have a look at some of the Slido questions that have come in then. We have, it's just disappeared from me, Jenny. I know when I was looking at it before about people who were retrofitted different types of arc flash mitigation on there was a number who actually had. What you couldn't answer is what type of things that you put on there. So I don't know if there's something that people want to put out there. What have we actually put on? Different types of arc flash mitigation? I'll take voices from the audience, but that's okay. All right. Remote switching. It's a very simple one to apply into the remote switching. There's different methods, whether it's hardwired into the systems or actually flying lead type systems, but there's an awful lot available out there. I know when we first started it many years ago, there weren't many options at that time. Absolutely. Yeah, no, you're right. Just to clarify that, yeah, legacy system is perfect for that. So retrofits on them, it's dead easy to fit. Standardized solutions for that, and it makes it very, very easy. Very cost-effective system as well, because you can actually move it from one equipment to the next. Okay. Sorry, what was the other slide, or Jenny?
I think it was on what have people put in, I think was the other one. So, yeah.
Okay. So the next set of questions up here then.
I've got the results for those polls if everyone's interested to want to. 2 seconds. So first of all, the first one was oops, it opens up. There we go. So the first one was, has your company retrofitted any output mitigation measures to older equipment? And it was 35% yes, 65% no. And then the next one that we had was, it's gone. Here we go. Okay, so the next one, which of the mitigation measures does your company use on existing equipment? So remote switching was number 1, 56%, interlocks at 32%, operational measurements without opening cabinets, thermal imaging, etc. was 6%, electrical protection maintenance mode 5%, and then 0 for light detection systems. Hope that helps.
Okay. Thank you. So thanks for that. And you say remote switching seems to be a very popular one in there. I say very easy to implement from that sort of side. And interlocks, basic safety system by design, should all be in there as a standard as such on that one. Okay. Right. Let's do some of these questions then. So, top one on there. Should arc flash risk assessment form part of the designer's risk assessment for all electrical designs? Mark, Jenny, who wants to take that one?
Yeah, I think if you're going to be speccing some equipment, you want to understand what you're getting. And at the point of design is at the point where you can see the risk, the potential values, and you might then decide to apply extra mitigation to lower it down. So yeah, 100% it should be part of the design. You should see it well in advance, and you should be able to input into having some extra aspects. There might be certain sensitive areas where you want it to be really, really low. So then you'd pay for some extra bits to be added in.
I think it's also making sure that the designers are on board and understand how much of an impact things like that can make the actual operation ongoing with the equipment. As it might be very easy to just look at the system as an electrical system, but to understand the further outreaching capabilities they can actually design in to begin with, and give them that knowledge in the first place will be a massive help, I think, moving that forward.
Yeah, then you bring up the discussion around the people involved in design, spec and install, and not always the people designed in day-to-day operations for the next 30 years.
Yeah.
So they look at their costs, it's only going to cost this much to build it, and they don't care about how much it's going to cost to do day-to-day operations and the potential to manage that risk. So that's where, operational safety people have the ownership of both of those processes. So they should be involved in that process from day one, in my view.
Absolutely, and I think sometimes it's important to understand whose responsibility that is. You know, as equipment designers, it's not always their opportunity to actually do that assessment. So as asset owners, you've got to ensure that that requirement is in there as well at that point. Okay, so moving on then. Why is arc flash risk assessment not a requirement when installing a new system? Why isn't this being put into legislation? I know we've talked about this all the time and what's happening with legislation. It's a difficult one. There are bits in there. We do recognise that there should be a requirement to have it in there, but Jenny?
Yeah, it's like with any legislation, often the legislation lags the technology. So if you're an early adopter of the technology, often the legislation won't be there, but hopefully it'll catch up over the years.
We have a legislator in the room. I don't want to put him on the spot, but would he be free to speak up and give us a bit of viewpoint from the legislator's perspective? No takes.
My understanding was that if you'd installed a new equipment from 2014, then it should have been supplied with an arc flash assessment. Prior to that, it didn't need to.
Okay.
So if you've got older kit, then you'll have to go in and get an external one. But if you've had it built from 2014 onwards, then the manufacturer should supply it as part of the design process.
Yeah. And that's effectively its testing at that point, isn't it? Where it sort of sits into your system and its incident energy levels are a completely different matter at that level, aren't they? Yep.
But again, it's different between HV and LV, isn't it? I don't
Yes.
Yeah.
There isn't the requirement to have LV ones at the moment, arc flash rated, where there is for the HV.
So a very specific question, which is, what is Schneider doing about providing remote racking in and out of trolleys and remote switch devices for LV systems? I'm not quite sure why we picked on Schneider, but I guess that could be any manufacturer to sort of ask that question. What can we do?
Yes, I suppose all manufacturers has their own solutions. In the Schneider, especially for the new technologies, we have this remote control with the smartphones or iPads that in the safe distance you can operate the circuit breaker through the relay with the smartphone or iPad. Of course, there are some questions. This could be raised a cybersecurity risk, but there is a necessary cybersecurity measurements in the device and technology, and hence it's only in the safe distance, which someone from on the street cannot interact any kind of technology. Plus, we have also, remote thermal units and also the software technologies that we can utilize remote operations. But in this switchgear substation, especially for the technicians, we have these smart and iPad technologies that we can operate.
Okay, thank you. And does that actually do for racking in and racking out the equipment as well, or is that just purely operation, as in isolation re-energization?
Yeah, I mean, you mean the circuit breakers? Yeah, of course, there is withdrawable the circuit breakers, like a disconnector, you can remove it, and when you need to do, after you finish your maintenance, then you can put in service. This is also other technologies we have.
Okay, all right, thank you. Safety rules. We talk about procedures and programs there. Do you think there's a place for cross-company review of safety rules, agreed variations, operating procedures, allowing comparison and benchmarking? Mark, I think that's the wind industries have got a real challenge at this moment around there, haven't we?
Yeah, cross-company safety rules. If we could all use the same safety rules, wouldn't life be easier? And have the same procedures, the same processes. Then, we could share resources, we'd spec all the same kit, we'd understand what we were doing on every asset. 100% that would be fantastic. Whether it's going to happen, not too sure. Like I mentioned yesterday, in the wind industry, we do have the wind turbine safety rules when working on low voltage. That is in the UK quite a standard way of working, which most companies follow. So, we're halfway there. The beauty is, I think in the wind sector, we can try and standardise, we can try and align, because we can focus it very specific on certain areas, certain aspects, and then that's fit for purpose for that specific industry. Absolutely. But to try and spread it across everywhere, you've got to get so much buy-in from so many people, and so many different ways of working, and it would be a real challenge. I think you need to pick your battles. Maybe the winner is a little bit more standardisation towards HV training, and then which everybody gets on board with, and maybe that's just the basics, the starting point. But at least any person that comes into any of the industries with that is 20% into the training from day one, and then it's just familiarisation with the company-specific stuff. So I think that could be where we where we can benefit in every industry at that point.
And I think that's part of the conversation we had yesterday.
Yes.
About what do we actually need for somebody to go work on a wind turbine? Do they need to be fully authorised as part of a DNO and a distribution system, or are you talking single-ended feeders to a generator?
Yeah, you really need to understand the competence needed. Definitely.
Exactly, absolutely. And
With the safety rules point again, there's also the advantage that if you've got the wind turbine safety rules, everybody's working to the same marks issues with the 3-position switches. It sends a clear signal to the manufacturers that these are the safety rules that are going to be used in every turbine in this country. Therefore, your kit needs to be fit for purpose for those safety rules.
absolutely.
While there's ambiguity, there's confusion for the manufacturers. So I think that's an aim.
Yeah, no, that's good. Okay. Yep,
Yeah.
sorry.
Sorry, just going back to the conversation with the safety rules and the collaboration between different sectors. The power generation sector, we've just got our first edition last year of the Safe System Work Package across different companies. So it's a template for the safety rules, safe systems of work, and that's through through Energy Institute, who I'm a member of. So that's something that we've done. Again, it's not mandatory. You don't have to follow it exactly, because all companies, as you said, have their sort of specifics within their safety rules, but that's a template someone can pick off the shelf. And if they're starting from scratch for smaller companies, they can use that as a template to go with. So it can be done.
Yeah. Yeah. And there's the model distribution safety rules is one. Again, you can take that off the shelf and use that, adapt that for your business. There are some out there, but there's always subtle tweaks. There's always subtle changes. That's what people need to be competent on if they're going to work there. I don't believe we're going to stop that fully. I don't think we'll be able to.
No, and I think if you can actually develop that, a standard set of procedures, as Energy Institute's here, an institute there, and I'm sure there's some that we can use from the wind industry as well. Standard format there, and actually develop some standard training courses as well. Yeah. If we all agree on a standard training course for their requirements, it makes it much, much easier to progress in it.
I think that's the quicker win.
Yes, exactly. Some more questions on here then. Arc flash protection seems to be the buzzword. I think that's true. I think we've all mentioned arc flash once or twice in our presentations. Is it going to be a trend like RCBOs? I think it's a bit more than a trend, but Ersin, do you want to?
Yeah, I mean, nowadays we receive inquiries, especially the data centers, marine industry, critical infrastructures, and even we heard that some of the companies are including in the insurance policies terminology. That's increasing, of course, again demanding. But we are also talking with the distribution network operators and other industries and segments. I think one query is, okay, we have IC standards for MV. They were also waiting for the article and standards from IC again for the LV network. And in the meantime, they want to see the pilot applications, and one of the leader in the DNO industry can apply this, and if they start it, and most likely the others will also follow the route. If we consider the high industries like steel plants, cement plants, yeah, there are also quite a demand from these segments. But I believe in soon there will be more applications in the industry, yes.
Yeah, absolutely. Okay, so yes, I think arc flash may be the buzzword of this event, but I think arc flash is becoming more and more prevalent in the UK. I say, from my sort of stance, we started on the refinery back in about 2008, 2010. There weren't really many people at that time. It was interesting the way the HSE did challenges on actually implementing arc flash mitigation measures at that time. I think since then we've had subsequent reviews and discussions with the HSE, and actually they've come on board with where we've actually taken our systems. So there is a change in mindset in the UK as well around arc flash. So you've seen that over the last few years. So it's moved away from it's American, why do we need to do it, to sort of say, no, actually, this adds to our safety program, why aren't we doing it? So I do see that change now. Ersin, this is definitely one for you. How do you test optical flash detection?
Yeah, good question. So torch With the torch, we can test the optical sensors. We need to make sure that, because these relays now, new technologies, they are talking between each other. And when we are testing it, of course, we will be isolating this circuit from the bus bar, or all bus bar will be completely de-energized. But if the relays are talking between each other, it may trip incidentally another a relay in different part of sections. So in that respect, we need to make sure that the network is disabled, and then we can test it with the ORC. I sometimes received questions regarding daylight. Is it going to be impact the daylight? No, it's not that sensitive. And plus, if we need more protection or application, then we can use the current protection as well.
Yeah, I've seen that before, where you do a combination of current and optical.
Flash, yeah.
I think as engineers, we can be a little bit reluctant to take on new technology, especially as older ones.
Yeah.
And you sort of think, oh, optical, how do I manage that? How do I test it? How do I make sure it all works? So yeah, it's good from that sort of standpoint.
Yeah.
Okay. And again, I think another one for you, Ersin, and I think you sort of touched on this in your presentation there. Arc flash detection systems are very challenging and costly to retrofit. Which mitigation really provides that best value for existing equipment?
So yes, there are. So we have some inquiries that because the modernization retrofit is one of the main purposes, to reduce the outage duration and increase again productivity, and they want to do it during the maintenance time, to do the maintenance in the meantime modernization. Modernizing, for example, electromechanical relay with a new digital relay, it may take time. Instead of they want to improve the protection application. So another option is using arc sensors with the arc flash next to the traditional protection systems to improve the application as well as reduce the outage duration. So yes, we have some experience and references in that respect.
Okay, that's good. And I think a question that we all sort of wonder around this is how reliable these systems are.
Yeah. As a representative for the technology owner, I would say it's highly reliable. But there is, of course, we have the test, we have type test, we have a routine test. We have also the certifications in that respect, and we have also references. So for this question, we can organize maybe a demonstration and trainings just to prove it's quite reliable. But evidence is with the test that has been already done.
Okay, thank you. Mark, one for yourself here. So what prompted the full review of the procedures by Equinor then? Was there an incident or was it?
No, no, there was no incident, sorry. There was no incident, it was just based on the arc flash calculations.
Right.
There was obviously areas which was higher for the arc flash risk. So basically we wanted to try and just make sure we were mitigating that. Are we doing the isolations in the right place? Mm-hmm. Are we not putting people at harm? We suddenly knew that we had this risk to manage. Yep. We always knew it, but we had figures to put to it. So then, are we actually doing the hierarchy aspect, like I mentioned?
Yeah, no, that's good.
Are we stepping away from it? Are we doing a downstream isolations? Yeah. Are we doing it with isolated with the door shut? So.
And I think that's one of the things I always sort of challenge our team. We look at work and we put measures in place and say, oh, we're doing this safe. And I always sort of challenge the safe. It's not, oh, we're doing it safe. Is there a safer way of doing this? Yeah. And it's having that mindset to say, is there something else we can do? What's our next step? And realistically, that sort of comes into the next question then. What's a practicable level of acceptable arc flash risk within your business? Go for it, Jennie.
Well, we've had this conversation. It's like kind of, would you want your child standing in front of that equipment? It comes back to that one, doesn't it?
It's a great leveler.
It's kind of, yes, there is cost implications. It's risk. You've got your hazard, you've got your likelihood. If you could bring your likelihood down, it reduces the risk. So there's various risk assessments, but at the end of the day, you are talking about people having life-changing injuries, or the worst case, fatalities. So that's an individual company decision.
We've spec'd that on design, everything should be 8 cal or below before we'll accept it. And if they can't get to 8 cal or below, then we have to have some sort of mitigation process or understand the risk for why it can't be achieved. But that's actually in our technical requirements when we go to design.
Yeah.
So we're trying to design out at the start. And then that aligns with our PPE expectations, so they're all kind of linked together. This 8 cal is the spec.
Yeah.
As you saw in that video, the difference between 12 cal and 1.2 cal. Even if you've got the PPE, you still don't want to put people through that.
Absolutely. And I know for our sort of side, we've tried to keep it simple around the PPE. We have one standard of PPE. We have 40 cal PPE suits. That's it. It's a question around competency of not only the people who've done all the work in the front of the engineering teams, it's the technicians, and that's sort of, there's a question there. We're asking technicians to do more and more HV work. How much of this do they actually understand? And what do we do to ensure that we've got competency in that field? From my stance, I've always said, let's keep it simple. Jennie, Mark, Ersin, how do we manage the technicians that are coming through with less and less experience in the HV world? We talked yesterday about training. How do we get them through? How do we get them to an acceptable level so they understand that risk?
As you say, there's simplification, and the simplest one is if they're not there, they're not going to get it wrong. But yeah, it's making your procedures clear, removing ambiguity, making sure they know what they're doing and they follow the steps. And as we've discussed before, why they're following the steps. We're not just putting these steps in to make your life awkward. We're putting these steps in for your safety.
I think the authorisation process doesn't change. Still, it doesn't matter if you're going for a limited SAP or a full SAP. You still have to go through the rules, provide a portfolio, have a mentor, do the training, have some exposure to the kit. If you only need to have exposure to one piece of switchgear that isolates a transformer, for example, then that's what you'll be authorised on. It's going to be quicker than being a 400 kV SAP because you haven't got to have the exposure to all of that or that some much of a system.
Yeah, absolutely.
So, but the exact same process applies. Do they understand the risk? Do they know what they're doing? That's all part of the training. They still go on the switching course. They still sit the internal training course. Everything is the same. It's just at what point have they provided enough portfolio to show they understand what they're working on. Means that limited process can, that limited authorisation can be applied.
Yeah, absolutely. The competency doesn't change.
No.
Somebody yesterday used the CATE acronym, which is knowledge, aptitude, training, and experience. All it means is if you're limiting the amount of work they're going to do, or work.
Well remembered.
Sorry, it was Richard, wasn't it? Yes, yes. Sorry, yes. I do try and listen sometimes. Standing and listening, and it's two things at the same time. It's tricky. Yep, sorry, go for it.
Is on? Yeah. Just linking back to the training and competence bit there, mindful, yes, we can sort of train people in procedures, we can take them through panels and processes, whatever. I'm thinking more at sort of UK PLC, maybe even global PLC. What are we giving, how are we dealing with giving people opportunity to access hands-on training with real equipment in a safe and controlled environment that covers both legacy, current and future application? So there's some amazing training out there, there's some amazing organisations, but when you look at the actual access to actual real bits of kit that relate to the actual work they are going to do, certainly the big picture I see is there's not enough of this out there. Yes, you can go on courses that get you close, but that is not the same as that experience with the particular equipment that they are being asked to work on. Noting in human factor environment, it is those differences and particulars are where the challenges and problems are live, not the generic.
No, 100% agree, but I feel for the training providers because I think they want to do it. You know, there's lots of big training providers out there who would love to have kit and have the people with experience to deliver the training and go through real life scenarios. But I don't know how many people there are in this room, but we've all got some switchgear of some description. I bet the majority of it's different. So how much, you know, for the training providers, their question is, what make do we want? What brand do we want? What voltage do we want? How much of it do we want? Should we have an open bar compound? Should we have just GIS? Should we have, you know, vacuum breakers? What should we have? And it's a challenge because they can't have everything. What they do need to provide, and most operational safety training providers have some operational kit, even though it's normally 11 kV ring main units, for argument's sake, or just a multi-panel board. The point of doing that training is, this is how I see it, the point of doing the training is that is your starting point. That is your awareness of operational safety. It doesn't matter how you apply on a bit of 11 kV switchgear in a hut in a car park somewhere. When you come away from that course, you should understand, right, I see the point of this. Now I know what I'm being told on my asset. I know what I'm being told at the 33 kV switchgear that I use. But I've had discussions with Apito and other companies to say, you know, they're saying, what would you like us to have? Well, I'd like you. I'll give them a massive list, but they're never going to pay for it.
I think picking up on that, Mark, actually, going back to the CAPE part, the CAPE part is only part of the assessment process, of which training is, for our aspect, only 25% of that. You can't train everybody on every piece of equipment because it's impossible. That's the point of the assessment. The assessment takes it that stage further. It's on site with the people who are using it through an agreed process, using an authorising engineer. I've got over 350 APs out on the ground at the moment dealing with every bit of different type of equipment you could think of, from 60-year-old to brand new. We use the same assessment process. It works. As I said yesterday, I've been doing this for over 30 years. You use that as the site knowledge, and people prove themselves on that site equipment. They don't prove it on what they've been trained. The training gives them the basic level of understanding. It's not about a training provider giving you everything. It's only part of that whole process.
Yeah. And that's the portfolio delivery, isn't it? That's the exposure to the kit, that's the understanding of what you've got, and then the portfolio shows the person who's going to be doing your authorisation interview, I can see you've got the knowledge, you've got the experience, you should be ready for this next step.
Okay.
Echo that. I spent 30 years as a working SAP. I trained on 11 kV equipment. I ultimately ended up isolating 275 kV grid equipment.
Yeah.
No training centre has that.
No, of course.
You've got to put your boots on the ground and go and find it out.
Yeah.
That's the
You've got to
responsibility
have
of an
the
SAP.
exposure. You've got to have somebody show you. You've got to build a portfolio to understand how it is, and that is the only way we can do it.
Okay.
But one thing with exposure to relays and things, that is something that you can, like when we were in Tex, we did actually set up a test substation, and they had the actual relays the guys had on site, which were our spares. We actually had them in racks powered, and they could actually press the buttons and read the settings and actually have them live. So that is useful if you're going to be switching via a relay.
Yeah, we've bought spares. You know, the beauty of building a brand new installation from scratch is we'll have a piece of that and a piece of that as a spare.
Why not use those spares?
You can get a two-phase supply on it and charge us coils, and then actually go through some training, and you're in a workshop. You know, you're not on the substation waiting for an outage to happen. So
Yeah, absolutely. And I think with the training, there is two parts of training that we sort of touched on there. There is the training providers putting that basic level of understanding, what you need to do with the equipment. And realistically, with the equipment, there's really only a few standard types. There's withdrawable, there's fixed patterns and such. They all follow a similar sort of format. Yes, they'll have different actual operations on there, but you will still be isolating, switching, isolating everything. It won't change. So it's just then familiarisation, which you actually do on site, and actually pick that up with your on-site training. I mean, like I say, it's building that level of knowledge up there to ensure people are competent to work on that. Now, I'm going to probably bring this one to an end now. I'll just sort of say we are recording this whole event. So we've not managed to capture all the questions that we've come up through on the Slido, but what we're going to do is take the panel to one side and we'll answer them questions, and they'll be able to be seen on the recording. So we'll issue that recording. I'm hoping it all goes on YouTube, and I'm going to be trending and I'll go viral on YouTube. That'll just, my kids will love that. Yeah.